Hey, everybody. We're getting started here. Of course, we have Alex Anderson, Senior Sales Engineer with a background in mechanical engineering. And we have Lee Rafdal over here, Technology Sales Engineer with a 20-year background in tool design. I'm Justin. I'm with Accumold Communications. My goal is to not talk that much today, so thank you, everyone, for joining us. Lee, Alex, thanks for doing this.
Yeah, thank you.
Who wants to, first, let's do a really, don't go too long, but first, maybe like a 30-second background on yourself, and then we'll get into the questions some people submitted ahead of time.
Yeah. Thanks for that. So my name's Alex Anderson, Senior Sales Engineer at Accumold. I've been with the company about 4 years. As was mentioned at the beginning, I do have a background in mechanical engineering. My primary role with the company is to be interfacing with our customers and then kind of being that conduit for communication between our engineering teams and our customers' engineering teams.
And I'm Lee Rafdal, Technology Sales Engineer. Been with Accumold almost 24 years. 20 years of that was in mold and tool design. Now I'm up front with sales, helping them technically, working directly with the customer on the front end with DFM and DFMM, and creating quotes.
Excellent. So I'll go ahead and, Alex, do you want to start with some of the questions in advance, and we'll just go either or, and I'll make sure to monitor the comment feed as well.
Yeah, so I'll just do maybe a brief overview of just for kind of the record on who Accumold is, if that's all right. So just in case anybody's not familiar with us, Accumold is a micro-injection molding company out of Des Moines, Iowa. We're in a suburb called Ankeny. We've been in business for 40 years now. We actually developed the world's first generation micromolder. Currently, we're sitting at well over 300 employees, ISO certifications. We have everything we need from a medical device manufacturer. And right now, we have around 130,000 square foot facility with a 24/7 operation, Class 8 and Class 7 clean rooms. Could probably go on more there, but that's not the focus today. So thanks for that. And then from just kind of like the key points, I think maybe it'd be good to define like what DFMM is and just kind of like what that means to us. So Lee, I know you and I talked a little bit about this, but could you maybe just define DFMM and kind of like just what that means?
Sure. So, there's DFM, which is design for manufacturability, and then we talk about DFMM, design for micromolding. And when we talk about design for manufacturing, we have customers that don't have any molding experience at all. So that may entail us looking at their model and saying, okay, this part can't actually be injection molded at all the way it's designed. And that's not their fault. They just don't know what the limitations are. So we'll help them redesign their part in a way that's still useful for them, but we can actually mold it. Where DFMM, it's just micromolding. So that's not necessarily just micro size components. It can be a little larger component with micro features as well. And so that's kind of the key difference between the micromolding side of things.
Awesome. Thanks, Lee. I think one thing that maybe would be really good to just mention is like how this has been used in the past. So I got a specific project that I'll reference here. We had a customer a while back looking at making a design change for one of their components, but they had like 5 or 6 different possible variations that they could have been using for that component. And what we ended up doing is actually sitting down with them for an hour or two, looking at all of the different design options and then understanding kind of maybe what from a tooling standpoint would have to change to accommodate that, but also like, are each one of those designs possible? And we were able to filter those 5 or 6 opportunities down to 1 or 2 to be able to move forward with, which I think in the big picture is a huge timeline savings, but also is just a great benefit to be able to provide that type of resource to our customers. So outside of that, there's also some really good opportunities for just making components manufacturable and scalable, right? That's a big thing. Not making just 1 or 100, but 100,000, million, 10 million, that type of thing. Maybe one of the things that I'll also highlight here is kind of just how we provide that DFMM to our customers. So Lee, I mean, in any situation where we're working with our customers, typically it's, we're finding time to meet, hour, 2 hours, whatever it is. And then how do you like to see it kind of play out? What is it of the best case scenario from like a preparedness standpoint for our customers to be?
I would say starting out with making sure we have a model and drawing if that's available to review. Obviously, the model is the most important thing for us. A lot of times a Teams meeting is where we start. You can share a lot of information both ways. A lot of times the customer will show us, assemblies where the part goes, so we can have a little bit more information of what's critical. Things like where we may be able to gate or not gate, depending on where the assembly clearances are. So that's a really good starting point. Sometimes we don't start off with a Teams meeting. It's more of a, emailing back and forth. Maybe we update a model and take screenshots and share that way. Of course, on-site visits are excellent as well.
Yeah,
and
I agree.
That's probably the best of all three. So.
Yeah. Just to speak to that a little bit. I mean, that's certainly something we offer to our customers, is the ability to come on site with Accumold, sit down with our, engineering team or our quoting team for, maybe 2 or 3 hours and really able to kind of rapidly address these projects. I know that's usually something we have a little bit later in the process, but it is just for everybody to be aware of. We do offer DFMM all the way from kind of initial concept all the way through to on-site. This is the final phase before we start cutting steel tools. So,
real quick interjection here. I am finding the best way to leave a comment is probably DM you guys, but also they can leave a comment right in the stream itself. I will be monitoring those comments, and the delay there's almost no delay in the comments. So if you leave a comment and you're listening right now on LinkedIn, or you have a question, if you enter that in, we will see that in real time. If you have really good zoom on your camera, you can see it's coming up on the screen right here. So we are ready for those comments and questions.
Nice. One thing I did have a question on. So Lee, you mentioned it's also helpful for us not to just have the part model, but the actual assembly. Is that just so we can understand what areas we can maybe push on, make modifications to, and not affect other things? Or what was your thought
exactly. there? With our customers, a lot of them are putting a lot of components in a very small area. So the amount of clearance from part to part is usually, very small, a thousandth of an inch or so, maybe less sometimes. And knowing which of those features are critical for the fit of the assembly is important. So we know not to even ask if we can put a gate there if we don't need it. Like it just helps us make those decisions based on the actual assembly. I think that speeds things up as well. We're not like, hey, can we get here? Can we eject here? Do you have any keep out zones? We can kind of see that.
Okay. So I do see we have a question here for why do we provide DFMM to begin with? I'll maybe answer that on the first pass here and then see if Lee has anything to add. So from my perspective in sales and then kind of being that conduit between the customer and Accumold, the main thing that I see is like timelines, right? Providing DFMM early in the process, especially for some of these higher priority projects that our customers have, really helps us save total time when we're looking at the timeline from kind of a zoomed out view, because maybe that DFMM helped us, not have to build multiple different prototypes, or maybe it gave us the confidence to go into a hardened steel tool for production right away. I think that can't be understated enough, is like the timeline impact is huge. And then I would say just making sure that it's like actually possible to make these. But like Lee, I mean, like the scalability, I mean, maybe you could comment to that about how, having that DFMM early helps us scale.
Yeah, I mean, it's important that we have a game plan where we are going to have a robust tool. And so having those discussions up front can really help that out. We can kind of steer them in a direction where, hey, this right now, the way you've got it, this is a very fragile piece of steel. It's probably going to, wear and break and have to be replaced frequently. Nobody wants that for their production tools, right? So, being able to help them see the reasons we're asking for the questions too, of why, hey, can we change this?
Yeah.
And this is why. And then they're usually pretty open to that.
Okay. Yeah. Yeah. I mean, it's, I think there's something to be said that like, you know, making one of anything or even 100 of something is good, but being able to make 1 million or 10 million is a totally different conversation. So that's really where that DFMM I think shines the most from a sales perspective, is like understanding and setting those expectations that this is like a robust solution for now and a year from now as well. I do have another question on, so not why do we do the DFMM, but like how do we actually communicate that information to our customers? And Lee, I know you mentioned a second ago, I mean, Teams meetings, being on site, those are all really great things. But maybe like probably one of the more common examples is just, you know, screenshots in an email, right?
Mm-hmm.
Like that's probably what we're doing the most of. And do you have any information there that you could share on like how you do that? Go in and look at the bottle and stuff, or?
Yeah, I mean, it's just you know, we go as far as sometimes making splits of showing them where all the steel transitions are on the part.
Mm-hmm.
We can, you know, give different colors for the different faces so they can clearly see what our plan is. We have an area marked as a gate that's clear. Ejector pin marks. On the front end, we may not have all of those things for them to see.
Sure, yeah.
It might come a little later after, you know, we're in design. But yeah, I mean, screenshots are a great, quick way to send them something. Quick question. Hey, can I put a gate here or not? Just real simple.
Yeah. Yeah. I think you and I were working on one just earlier this week where there were some screenshots going back and forth where a customer had provided us with a model for a component that's currently being machined, but they want to convert over to injection molding, which is like a classic great example for designing for micromolding. And I think in that situation, you ended up sending me like a screenshot in the assembly file saying, hey, can you I made some modifications. Could you check and see with the customer, like, is this still going to work? Just kind of
that's right. Yeah.
setting that up ahead of time. Yeah.
And that part definitely was not set up well for molding.
Yeah.
It was a machine part. So
Yeah.
being able to, you know, remove a chamfer here and add a little draft there, that sort of thing. Yeah. In that case, their model was not set up for what they are asking us to do. So I provided them with a model of what my interpretation of what they're asking us to do.
Yeah.
And then they can review it and say, yes, exactly, or no, not quite. And we'll go from there.
Real quick interjection here. We do have a question from Brett, but Brett, we're going to get right to that question. But before we do that, is this a normal thing where people submit design plans to you, to the Accumold DFMM team, and they're not quite there? Is this a normal thing? And how do you deal with that? Is there a standard way you deal with that? And that could be either Alex or Lee.
Yeah. I think I'll maybe kind of take the first part of that. So, I mean, that really kind of comes down to kind of a core part of my job is like maybe fielding those types of questions and then understanding kind of what does this customer need from us? Do they need us, you know, to provide just a little bit of tweaking feedback, or is this, you know, we're going to be sitting down and investing a lot of time and effort? But yeah, Lee, if you want to maybe kind of take it from there, that was the first part of it.
Yeah. I mean, it's a range, right? So we have customers that come to us with a very finished part design. And sometimes they don't really have much room for modifications at all. So in those cases, you know, sometimes we have to get creative in our tool design to create the geometry that they are saying they have to have, right? Other times they come to us early on in their development of a project, and they really have a lot of open area for design changes, right? So those are the ones where, you know, the DFMM might actually take several days or weeks, depending on where they are in their design. So
You mentioned a key word there I want to push into a little bit. You mentioned early on. How early should someone come to you with design plans? Should they come at the stage it's like back of the napkin? Should they wait for it to be a little developed? Just to ask the question, what is the right time, like a quality engineer or an engineer should come to someone like you with a plan?
Well, I would say the earlier the better if they want our input on how to go about things, right? So there's no right or wrong answer on that, I would say. I mean, it just kind of depends on how much our customer knows injection molding, and some of them are they know injection molding as much as we do, right? They're molders themselves, and so we get parts from them that are ready to go usually.
So unless you have anything to add to that, I'm going to ask Brett's question. And then I also know for those of you who has submitted questions in advance, we're definitely going to be getting to those as well. The question from Brett is, at what size should a company consider micromolding, and when should they contact Accumold for DFM?
Yeah, I think that kind of blends in with the previous question. So when we're talking about like the size of the component, I mean, the size of the component can be anything that's within Accumold specialties. So kind of just to define that. So Accumold focuses on what we call micro injection molding. We define that as parts that are physically small, micro size. It could also be parts that are larger. Maybe they're 4, 5, even 6 inches in some dimension, but they have micro features. Or it could be parts that are large or small that have micro tolerances. So the what size of part could be anything within that spectrum. And then the second half of that was, and when should they like reach out to us?
Lee kind of answered that, I guess. So
yeah, but no, it's a great point to just kind of really double down on as kind of like our areas of focus. And then when in the process, I mean, I would argue that the earlier the better, just so we can start understanding and communicating. Here are our capabilities. A lot of times we see projects designed based off of what people perceive our capabilities to be, which oftentimes kind of gives them an overly constrained or overly conservative design, when in reality, we could be maybe much more aggressive with the design, thin wall molding, aspect ratios, material selection, stuff like that. So I would say as early as possible, but it could also be at any point, right? It's when our customers are ready for it as well.
Is that a frequent thing where people, after you start dialoguing with a designer, where they realize that the original plan that they had considered or thought of was actually doable, but they didn't think it was?
Yeah, I mean, that's part of it. I would say what happens certainly a lot is, we can typically make devices or parts, components smaller with thinner walls and more compact than what most people expect. And oftentimes those, aggressive ideas at the beginning are ruled out because people just aren't familiar with what our capabilities are. So yeah, I would say that certainly can happen. Yeah.
I would agree. Yeah, that's happened before.
Yeah. I do have just kind of another question, so it's more of a comment here. But it's like, how do we design parts knowing that these tools are so small? So like, I think it's maybe more to the steel side of it. I think an answer to that is we have an on-site tool room 24/7. I mean, I think we have, I don't know the exact number, more than 55 tool makers right now with all that support staff. I would say having a lot of confidence to being able to make those parts out of steel. The steel to make those parts rather. Some of the parts that we make are, 800 micron is their largest dimension. So it's like, when you think about trying to design the steel, using CAD or whatever platform, be able to kind of design it ahead of time, and then just having the confidence to actually build the steel to that, I think is critical. Here I do see we have another one. So, what are the real world pitfalls, and how do we try to avoid those in micromolded components? Yeah, Lee, do you want to maybe talk about that a little bit, or kind of like what are the main areas that?
Yeah, sure. Thin wall molding, there's a point where there's too thin, right? There's limitations there, especially with aspect ratios, right? So you can't have something that's tooth thou thick and, half an inch long. It's not going to fill. But if it's a small enough ratio, then, we might be able to work with that. The material also makes a big difference.
Yeah, material's huge.
And sometimes we have the ability to get the material changed to help with filling their part, and sometimes we do not. So that just kind of depends on the customer's needs. We have parts that are so tightly tolerant that it also becomes a bit of a challenge for our quality department to measure them, right? So that's another thing, you got to think of when you're looking at a print that's they may want like plus or minus 1 micron, and it's like, well, we can't probably realistically measure that consistently. So, yeah, we would offer, try to get them to maybe open up some tolerances if they're that tight, but.
Yeah, I think just another one of the pitfalls that I'll maybe double down on there was you mentioned material selection. I think a lot of times, specifically in like the medical device industry, there is an attraction to a few key materials because they've worked really well historically. It's just important to remember that not all materials mold the same, and you may not be able to achieve each design in every material. So while DFMing the part itself for the features and the compact size and all that other stuff, equally as important is understanding kind of what are your acceptable materials that you can use, and then how does that balance with the features that you're asking for. Because I think like you mentioned, at the end of the day, there are some things, a material like PEEK, for example, is kind of like molding with concrete, right? It's not going to be able to achieve the same things that you could with maybe a polycarbonate. Just something to be aware of, but that's also certainly a critical factor in designing for these micro-molded parts.
I'm glad you brought it. Are there any other material pitfalls or materials that are underselected? Does material, I think a lot of engineers are familiar with or familiar with injection molding, but when it comes to micro, do you see material behave differently than it normally would? And are there certain materials that you recommend or don't recommend? Does it depend on the project? There's a lot there.
Yeah. So I'd say first and foremost, we're typically not going to be making direct material recommendations. If we are in a situation where that's being asked for, we have basically like our resin supplier experts who can provide technical staff to be able to say, hey, they are the ones actually making these polymers, and they can make recommendations based off of that. But a huge part of that is knowing like what is this device or component going to be doing, and do you need it to be rigid? Do you need it to be pliable, robust, right? The durability. There's a lot there that we don't want to just necessarily recommend a resin based off of, okay, well, it will fill this part. It'll make a really nice looking part, but it may not do what you need it to do. So typically we're not providing direct recommendations, but we're certainly part of that conversation and understanding, okay, the mechanical properties, do they line up with what you need? And then also, can it be something that we can actually manufacture? I think it's, multiple legs to that chair there.
Cool. I would encourage anybody streaming right now to go ahead and get your last second questions in before we wrap this up. So we'll hang out just for a second, but I would make sure to DM or leave a comment immediately so that we don't wrap it, but we'll give you just a second.
All right. Well, we didn't get any other questions. Thanks for everybody who joined with us, asked questions. I do want to just kind of like leave a little bit of an action here for everybody who wants to have reach out to us. So Accumold, you can reach out to us. We have our mainline phone numbers, but also if you want to get a hold of me, my email is aanderson@accu-mold.com. Feel free to reach out to me with comments and questions. There's a whole team of sales engineers and then also inside sales that can help answer and field those questions depending on where they're coming from. So really looking forward to hearing from everybody, and thanks for joining in.
Yes, thank you.
Oh, also make sure you follow us on LinkedIn here, both the Accumold page and then Lee and I personally.
All right, everybody. And I'm Justin with Accumold Communications. Thanks so much for stopping by. Make sure to follow the page because we're going to do more events like this in the future, and we'd love for you to join us. Thank you, everybody.